In this video, we will be performing basic static analysis on the malware fakeantispyware.exe. We will not be running the malware in basic static analysis to determine its behavior and functionality. So in this section, we will be loading the malware into VirusTotal to see if the malware can be detected by antiviruses. We will also create hash of the malware for fingerprinting, looking at its strings, dynamic linking libraries, and import functions to try and determine the function of the malware. So firstly, we will load the malware into VirusTotal to see the amount of antiviruses that can detect the malware. As you can see from this screenshot, only 46 of 70 antivirus is able to detect this malware. Next, we will be checking if the malware is packed before going to looking at its strings and DLLs and imports. This is because malware authors would usually pack a malware to make their files more difficult to be analyzed and to also turn a known piece of malware into something new so that the malware scanners cannot detect it. So firstly, we will check for packers using PEID. We will open up PEID, drag and drop the malware into this application. As you can see, PEID detected that our malware is using UPX packer to pack the malware. Also, under the section viewer, we can see that the raw size is 0 for UPX0. This means that UPX0 does not take up any space in the disk, but it takes up space in the memory. This might be an indication that fake anti-spyware.exe unpacks itself in the memory and stores it in UPX0 during runtime. So to confirm our findings here for PEID, we will be loading our malware into dependency worker. We'll minimize all the DLLs, and as you can see, there are 5 DLLs presented, but for each of the DLL, there are very little import shown to us. Maximum 4 and minimum 0. This is an indication that the malware is packed. Now we know that the malware is packed, we will need to unpack the malware. There are 2 methods to unpack the malware. One is via the manual method and the other is via the automatic method. So in this video, we will only be showing the manual method, which will be unpacked using only debug and also Scylla. Scylla will be used to fix the import table of the malware. Firstly, we will open only debug. Before we start, make sure that only dump plugin is being installed into only debug. This is used to dump the debug process later on. So now open only debug, drag and drop the malware into it. The alert box shows that the malware is being compressed or encrypted. We already know about this previously, so we will just continue on. Okay. So here you can see that the first instruction appears to be push AD. This is usually the first instruction depending on the UPX version. This instruction is used to save the current registry status where it will be restored at pop AD instruction later on. Okay, so we will now step into the code and then we will arrive at the next line of code. At the right hand side, we will select the first ESP value and follow it in down. At the bottom, we will select the first 4 value and set a breakpoint. After the breakpoint has been set, we will run the program. Now we arrived at the breakpoint that was set earlier on. We scroll up, you can see that pop AD instruction is here. This is where the registry status is being restored. We can also see that there's a tail jump at 0043B54B. This is where the last process for unpacking will be done. We can also see a jump instruction to 00412C8F. This is the location where the actual program will start. We will set a breakpoint at this jump instruction by pressing F2, and we will resume the program. It will stop at the breakpoint, and this is where we step into the code. Okay, so the first line now is called push EBP. This code is where we arrived at the original entry point OEP of the code. So we will right click the code and dump debug process. So here we would like to uncheck the rebuild import checkbox, as we will be fixing the import table using Scylla. So for the OEP address here, we might want to copy it for later use in Scylla application. We will dump this process in desktop for easy accessibility. We will name it unpack. Save. Okay, so now we will open up Scylla. Okay, in Scylla we will select fake anti-spyware.exe that is being currently debugged in OD debugger. We will change the OEP to what was previously copied and select IAD auto. After that, we will get the imports. As you can see, there are some invalid imports here, and we will get rid of them. After that, we will fix the dump. We will select the dump that was previously saved earlier on. Here, this just appeared, and this is the unpacked process of unpacked version of the fake anti-spyware. Okay, so now we can see the difference between the unpacked version and the packed version. So using dependency worker, for the packed version, we can see that there are very little imports shown to us. So now we will look at the unpacked version. As you can see, for the unpacked version, there are much more imports being shown to us in the import table. This shows that the malware has been unpacked. The difference can also be seen in PID. When we drag the unpacked malware in, packed malware in, we can see that it detects the UPX speckle. So when we drag the unpacked malware in, we can see that it detects the compiler for the malware. So first, there is also a difference in their hashes. So for the packed malware, this is the hash for the packed malware, and this will be the hash for the unpacked malware. Okay, next we will be using dependency worker to look at some of its imports. Oops, hold on. Okay, so for the first DLL, it is is a DLL that provides common GUI component that will be used by Windows application. This is a necessary process for the PCs to function properly. For kernel 32 DLL, it provides with the capability to access memory, input-output operations, and interrupts. For OLUT 32, this is a non-system process, a library that is used in Microsoft for object linking and embedded automation technologies. It allows the application to handle files and information created by other applications. For Shell32, it is used to open web pages and files, a library that holds Windows Shell's API functions. For User32, it provides Windows user interface functions to control graphical user interface such as Windows handling basic UI functions. So for the first import, we have init command control. This is used to index and initialize specific command control window classes. For kernel 32, we have create directory to create a new directory and assign security attributes. We have create file to create a new file or open a file if it exists. We have create event to create or open a named or unnamed event. So we have create process. To create processes, we have delete files. To delete specific files, we have find first file. This is to find the first file that matches a specific pattern or name. Find next file is to continue the search from find first file. So we have also get current directory. This is to get the current directory for the current process. We have get current process. We have get file size. Get file size is used to get the size in bytes of a specific file. We have get file type to get the file type of a specific file. File types such as character file, disk file, socket, pipe, unused, and unknown files. This is to get the full path name of a specific file. This is to get the process address. This is to get string. Also, we have to remove directory. Set file attributes to be set to a file directory. We have set file pointer. We have set file time, date and time for the specific file. We have sleep. This is to temporarily stop the execution of the current thread until the timeout interval has exceeded. This is terminate process, is to stop the specific process. You also have write file, write to a specific file or input-output devices. Next, we have system allocate string. This is to allocate a new string and copy the past string into it. This is to clear a variant. This is to perform an operation on a specific file. We have dialog box param A. This is a dialog box from the dialog box template resource to be created and used by the application. We have kill timer. We have load string. Load a string resource from the executable file related with a specific module. We have send message. This is to send a specific message to Windows. We have message box. This is a dialog box that contains system icon, buttons, and a brief application specific message. This message box will return an integer value that indicates which button the user has pressed. Post message A. Post a message in a message queue associated with the thread that created the specified window. This is all for DLLs and imports. From here we can see that It might be asking the user to install something as it uses a message box and button function. It might be asking the user to install an application or some sort. So they also have a find first file and find next file import. It might be that the malware will attempt to scan the computer to search for a file that match a certain pattern to do something. What it will be doing, we can confirm it later at basic dynamic analysis. Okay, next we will be looking at some of the strings in bin text. This is the automatic unpack version of the malware. So here we can try to see the strings. This is the compiler for the malware. They are checking for space in the computer. There is some pattern for hour, minute, and seconds, day, month, and year. The month, the day. These are all the DLLs that we've seen in dependency walker previously. These are all the imports. More imports. Message box. As you can see here, after message box there is a install and install end string. This might be asking prompting the user to install something on the computer when the malware has been ran. So they are closely associated with message box and post message A. Further down, a lot of gibberish words. Okay, at the bottom you can see there's a host-based indicator called setup.exe. This executable file might be created once the malware is being started. Setup.exe is usually an exe file to install a certain application in the computer. So we can see that it's using 7-zip application. And other stuff. At the top we can see that there are quite a number of URLs. They are all linked to verisign.com. It might be associated with the certification authority or getting some signatures from this website. We cannot be sure about this, and we can clarify it further in basic dynamic analysis. Yep. Further up are all the gibberish words. Here once again is a repeated string of what we've seen just now. Verisign. Sub.exe. It's the same thing. Nothing much can be shown from bin text except for these few strings. In conclusion, for basic static analysis, the malware might be trying to get the user to install an application and perform a scan on their computer. This is uh, this is not confirmed and just a guess from basic static analysis, which can be further confirmed in basic dynamic analysis. That is all for this video.